Good evening, all of you. Welcome you guys. Welcome you all. I hope we are live. So here. So will you please check this audio video is clear to all of you? Yes, tell me now. Is the audio video is clear to everybody? Yes, fine. Chalo. Let's continue our discussions. And we have a small announcement from this Unacademy. So we have a great new batches are going to start for this GATE and ESE 2024 के लिए. And you can see this thing here. These are the top educators team you can find. And so the new batches which are commencing from the January 28th onwards, you can see. And these are the 2025 के लिए भी. And you can have a look at now. These are the USPs for the new batches you can see. And you can have a look at now here these batches. The top educators are taking these classes in these batches you can see. And you can plan this. So try to plan this Unacademy subscription as soon as possible. So the before the price going to hike, you can use the code of B.V Reddy and to get the great discounts. To get a discount from Unacademy team. And so we are coming to fulfill your dreams. Stay tuned to all of you for 2024. And these are the ESC top rankers from Unacademy team. You can see. We are starting the IRMS batches. We are starting. These are the one batch for the all type of exams, IRMS and as well as CSC mains also. And you can plan this Unacademy subscription GATE plus UPSC combo. You can able to plan it. Right. Chalo, let's continue our discussion. And these are some problems we have completed in the yesterday. Let's continue the remaining problems. Yeah, these problems we have completed now. Till here we have completed, right? Yeah. Fine, we'll plan one special class. We can plan to discuss what to do before one day before what you need to do. And tomorrow we can plan one session to discuss and what's the plan you have to do. Right. So let's continue. As of now, we can continue the problems and take this problem here. A traffic signal cycles are what you tell me now: green to yellow, yellow to red, red to green. This is a cycle as you know. Now you can see now here, and the green is for how much seconds you can see here, and here the green is for how much time here, 70 seconds has to on. And the yellow is for how much time you can see, 5 seconds. Yellow is for 5 seconds. And the red is how much you tell me now here, 75 seconds. And total, can you tell me how much the time here, 150 seconds. Total how much it is, 150 seconds. Now you can see now total 150 seconds now. And you can see now here if a clock frequency given, clock time period is given as how much you tell me, 5 seconds is given. The clock time is given, time period which is given as 5, right? And this is the time period of a clock signal. This is the time period of a clock signal which is given as a 5 seconds. Now you can tell me now here how much duration, the minimum number of flip-flops required. So here each clock is a 5, so the total is how much you tell me now here, total how many clocks are there you tell me here in this 150 seconds, 150 by 5. So how many clocks are there required you tell me, 30 clocks required. How many clocks required you tell me, 30 clocks required, isn't it? As we know, one clock is a one mod number. So that means we need to design a counter having a, that is a mod 30 counter is required. Yes or no? We need to design this as a mod 30 counter is required. Mod 30 counters, to have a mod number 30, can you tell me how many flip-flops required? How many flip-flops required? So that means 2 power 5, which will give what you tell me now here, 32. So that means how many number of flip-flops required? How many tell me here? The number of flip-flops. The number of flip-flops are how many here? 5. 5 flip-flops required. Right. Next. And take the next problem. Consider the following circuit involving a positive edge trigger D flip-flop. Okay. Now, consider the following timing diagram they given. Let AI represent the ith logic level on the line A in the ith clock period. If A dash is a complement of A. Now the correct output sequence on Y over the clock period 0 to 4 seconds is, means what they are saying here, at this instant. So this is the input, they are calling this thing as a A0. Here at this location the input they are calling it as a A1. This is second clock now. Here at this location the input they are calling this thing as, what you tell me, this is a A2, and this they are calling this as a A3, this they are calling it as a A4, isn't it? Now they are asking to find the what could be the output in these cases. Now if you see carefully, what is the input of the D flip-flop? Tell me first of all. Input for the D flip-flop, which is given as here, this is A into X plus, what you tell me now here, that is Q into X bar. That is D is equal to, tell me now here, AX plus Q into X bar. So this is the input of the D flip-flop, right? Now as we know the characteristic equation of D flip-flop, that is Q plus, which is equal to D, Q plus, which is equal to D. So that means what we can say now, output is same as input only. Now at this 0th clock the input is a A0. What is the input, you tell me? A0. Can you tell me now what I'll get my output here at the 0th clock? So that means input we should have taken as A0, and what the X you tell me now here? X, which is equal to 1. At this location input X value 1 plus Q. Initially Q value, did they mention the initial value of Q? Let us consider initial value of Q I have taken as 0. And then what we can say now, X bar, which is equal to 1. So what I will get, you tell me now here, which is equal to A0. A0. So you can see now from this option C and D eliminated now here. Fine. Next, now at the Q1, at these locations, what is my Q plus, you tell me? So A value, which is equal to A1, at this location, what is the value of this X, you tell me? X value to 0 aina plus, and this Q means what now here? Previous output. Previous output is what we have, this is A0. Previous output, what we have, this thing here we have, so this value at this location, so which is equal to A0, and then X bar. X bar means what, you tell me now, which is equal to 1. So how much will get, you tell me, at this location, which is equal to, this is A0 now here, A0 here. Okay, fine. Next, at this location, let us call this output now here at the second clock. So that is q plus, which is equal to, what is a value given as a2 and x value here which is 0, plus at this location what we have the output. You see this thing carefully at this location. So previous output now here, which what we have, previous output what we have here. एक minute हमने कुछ, okay, this is what now, x bar now here, this is q bar, right? This is q bar, isn't it? q bar, मैं एक गलत किया, this is q bar, isn't it? So take the q bar. So q plus, which is equal to, tell me now here, that means ax plus what we can say, this is q bar into x bar. When at the first clock here a value given as a naught, x value is a 1 and previous value what I can say, tell me, previous value 0 consider kiya, so this is 1 and x value, x bar is 0. So which we got this as a naught. Next, tell me now here at the second clock here, which is given as a is equal to a1, and then tell me now x value which is equal to 0, plus what you tell me now, previous output which is equal to a naught bar, previous output a naught bar, and whatever the x bar you tell me at this location, x bar which we are getting this as x is equal to 0, x bar is 1 now, tell me, so which I am getting this as a naught bar. Now at the second clock you tell me what happened. At the second clock what I am getting now here, q plus, which is equal to a is equal to a2, x value how much you tell me, x value at this location which is 0, plus what I can say now here, at this location the input is what you can say now here, which is equal to, this is my a plus, this is what we are getting, you tell me, a naught. So this is q bar is equal to what we have at this location, which we have, this is my a1 bar, and then what we are getting here, you tell me, so at this location, so here which is equal to 1, so which you are getting the q plus, which is equal to, tell me now here, this is a1 bar now, tell me, which we are getting this as a1 bar, isn't it? All of you, right? Done. So this is option A, tell me, this is option A, fine all of you. Chalo, next problem. Previous output is a1, what here, previous output is how much? Yes, shall I repeat this thing all of you once again? Now listen carefully once again. Now first of all try to understand. Now let me repeat this thing once again here, listen carefully. Right, so this is what you tell me now, q bar. Yeah, tell me now here this is a q bar now. Now tell me what is the d, first of all you tell me, d which is giving, this is a into x, and here this is what you tell me now here, x bar into q bar now, x bar into q bar. So d, I can say d which is given as, tell me now here, ax plus x bar into q bar. As we know, d flip-flop, the characteristic equation q plus is equal to d. So that's why, so it will becomes what you tell me now here, ax plus x bar into q bar. This is a equation, tell me q plus first of all. Now at these locations, so the input we need to see carefully one by one. Now at this location, my input which I am calling this as for, tell me now here, ai is the represent the ith logic level on the line. So this is a ith logic level, isn't it? Now let's talk about this thing here, clock period. Now this is the 0th clock here. We'll call this as input. I am calling this as, this is what you tell me now here, at this instant, which is a naught. This is a naught, and this value which is equal to, tell me now here, this input is a1. And at this location, the input I will call this as, tell me now, this is a2. At this location, the input is a a3. Here this value which I can say this as, what you tell me now, so which will call this as a4, isn't it? Now you tell me now here, when, yes, when at the 0th clock, what is my q plus, you tell me? 0th clock q plus, which is equal to, tell me now here, a, what is this a, tell me, a is a naught, and at this location x value which is equal to 1 plus x bar which will be a 0. So that's why at the 0th clock, my output which I am getting this as a naught I am getting, right? Next, so this is my q plus at the first clock here, at the first clock. At the first clock, see what's happening, tell me. Values might be something different, might be. Take this value, option सही की गलत कोई गलत होगा क्या, I think so. Typing mistake might be here. So I think this problem we did previously also. एक बार check करके बोलिए. Value, this value, let me check once now here, these values, options. Anything differ they given. Modify, I think so. A1 bar, A3, A4. Yes, correct only. Fine, let me see this thing here. Now tell me now at this location, A will be which is equal to, what we can say, this is A is a A1, isn't it? Right. Next, what else now here at this location, X value, and what will be the X value, tell me now here. X value they has taken as 1, X value taken as 1. Here at this location, X value, x value 1, and then whatever x bar value, so 0. So this value which is equal to a1 na. Next tell me second clock q plus a is a a2. At this location x value, tell me how much it is, 0, plus next x bar means 1, and then q bar means which is a1 bar na, so that's why it is a1 bar. Next at the third clock, tell me q plus a value which is equal to a3, x value is a 1 plus x bar is 0, so which is equal to a3, tell me. So now you tell me now here at the fourth clock. So this means q plus which is equal to a is a a4, and at this location x value is 1, and then q bar x value to 0, so which is equal to a4. You see this thing here. So option A now tell me, isn't it? All of you do like this session, everybody? Now tell me, they given, if they given this number hexadecimal number, octal number. Now you tell me now what we can do here. They ask them to find x and y values. You see this thing here, 12 C 9. This is what now? This is hexadecimal number. Convert this number into a binary form. So we can each one, how we can convert now, each bit we can express as a by using 4 bits. 0, how we can write, to tell me now here? 0 0 1. 2 0 0 1 0. C means how much now here? 12. C means 12 now, 1 1 0 0. 9 means 1 0 0 1. This is the binary. Now I want to convert this into what now here? Octal number we have to convert now here. Octal के लिए क्या करो? So 3 bits we should combine now here. So I will take out these 3, and these 3 will combine, and these 3, yes. Now these 3, yes or no? Now how much this value, tell me? 1 1. This value is a 3, this value is a 1, and this value 1, isn't it? Now this number 1 1 3 1 1, this is in what system, tell me? Octal. And which given now here? So this means 1 1 x 1 y. This is a octal. I can equate the corresponding numbers, tell me now here. How much is x value? X is equal to 3 and y equal to 1. Right. Next one. Enter the next column. Consider circuit diagram. Now they given this one, this operator is XOR operator is given that D flip-flops are initialized to 0. The following data is supplied to as a data. So this is the data that has been given. So here now in 9 clocks. So here after the values, after the 9 clocks, they ask him to find the values now. Yeah, tell me what we can do here. Let's form a tabular form here. I can say this is my clock, this is my Q2 and Q1, and this is my Q0. Initially all the values of flip-flops are cleared, so all the flip-flops values are zeros. When the 0th clock, all the flip-flop values are zeros. Fine. Next, now you see this thing here. The first one data, which the data is coming now, 1 is coming. So this, when you after the first clock, you tell me now here, this Q0 is loaded with 1. Yes or no? Q0 is loaded with 1. And thereafter you see this thing, initially initially, so that means this value, so XR between the Q2 and Q0 will be entered as a Q1. Now what the XR between this Q2 and Q1? 0 0, which is equal to 0. Now tell me, and this value will be shifted to here. Yes or no? Tell me, did you understand this thing first step? Next, when you apply second clock, when you apply, what the next number will come here? 0 will be loaded as a Q0. Now the XR between the Q2 and Q0, how much it is? Tell me now here. 1. 1 will be loaded here, and then 0 will shifted here. Tell me all of you. Next, for third clock, in third clock, you tell me now here next one. What is the next bit? You tell me. 2 bits over now here. So that means third clock, this clock. Now that bit will be loaded here. Now XR between this and this, which is equal to 0. Now this is 1. Tell me. Next, fourth clock. Now next one here, 1 is loaded. 1. So this XR, which is 1, and this is 0. Next, fifth clock, you tell me. Next one is 1. 1 is loaded. So this is 1 and 1. And the sixth clock, 0. 1 1. So this is 0. This is 1. And the seventh clock, 0 is loaded. 1 and 0. Eighth clock, you tell me now. What you tell me now? 0 is loaded. Now XR, which is equal to 0, and this is 1. And the ninth clock, how many? 1 2 3 4 5 6 7 8 9. 9 only na here. How many here this thing? Ninth clock, 0 is loaded, and this XR, which is 1, and this is 0. You see this thing after 9 clock pulses. For the state, you tell me now here, and you can see the state now here. They are asking to find after 9 clock pulses. They are asking now here. This is my state of my counter. You tell me, which is equal to, yeah. So this thing 0 1 0. Understood? Tell me all of you. So this is a very beautiful problem. Any doubt in these things? Tell me. Chalo, next one. Yeah, take this problem. The control functions of the 4-bit binary counters are given below. Okay, they given this counter. Now tell me now what they are saying is, if the counter start from 0, assume the counter and the gate delays are negligible. If the counter start from 0, then it cycles to the following sequence. Okay, the counting sequence they are asking to find. Isn't it? All of you tell me. Now you tell me now here, what should be now here? What is the counting sequence of this counter they are asking? Look at now the input which is given as, you see this thing here, 0 input they given now, 0 0 1 1. These are the inputs now here. Now you tell me now kya hoga? You tell me. Whenever we are getting this thing here, that means what you tell me now, this counter, this inputs don't take here. Now, so tell me now here, when we are getting this is what kind of up counter? It will keep on will count now. Tell me. And see this thing, this is the clear. When the clear will get activated, you see, when the clear will get activated, if I call this is my Q3 and this is my Q2, this is my Q1, and this is my Q0. The clear pin will get activated when you tell me now here Q2 into Q0. In this case, my clear pin will get activated. So for the clear pin will get activated means for this case, what is the condition of the input you tell me now here? 0, Q3 is 0, Q2 is 1, and this is 0, this is 1. Yes or no? That means whenever we got the value of 5, then the counter will reset hoga na. Tell me clear pin will get activated when the clear is activated. So then tell me now here completely clears to 0. So then what happens, you tell me now here, the counting, this up counter will count from 0 to 1, 1 to 2, and 2 to 3, and 3 to 4. After 4 will get as a 0 will come. After 4 will get as a 0. So this is an option, tell me. The counter will count from 0 to 4. This is a mod 5 counter. Next. Next. Tell me now, a positive edge triggered D flip flop is connected to a positive edge triggered JK flip flop as follows. The output of the D flip flop is connected to both JK flip flop and all the given. So ये पूरा इतना कहानी दिया. So you need to focus about what you tell me now. Main thing you need to focus it now. Now tell me what will be the initial values you need to see here. Look at now here. The D flip flop is set to logic 1. Logic 1 is set to logic 1 and JK flip flop is cleared. JK flip flop is cleared. Okay. Now you see this thing. This is a D flip flop. This connection is here, not here. Okay, this connection is here. Now you see the D flip flop. D is connected to what you tell me now here. That is Q2. And JK flip flop. And the J and K value equal, which is given as what you tell me now Q1. And what I can say, this is Q1 and Q2. Now you see this thing here, what happens. And initial values of D flip flop is logic 1, D flip flop is logic 1, JK flip flop is cleared. Tell me now D is equal to Q2, so this value 0, and here J value, K value 1 1. Tell me now क्या होगा? 0 means 0 and 1 1 it will toggle now. Tell me. Next. So Q2 is what now? 1. J value, K value 0 0 0 0. Now D value 1, so 0 0 means hold state. JK flip flop hold state. Next Q2 is 1, so J value, K value 1 1. So this means D is 1. So here 1 1 means toggle. So what are they asking now here? So the same here, both the flip flops have non-zero propagation delay. What they asking to find? Whose output they asking to find? You tell me. JK flip flop output only they asking to find. Now tell me. You can see the JK flip flop. Is it possible to identify the option from this? Now Q2, which is equal to 0, Q1 is 1 1. So this is the 0 and this is the toggle. You can verify the options. क्या होगा? Only Q2 output is required. You see this thing here. So this is my Q2 output. Now tell me. Like this now here 0 1 1 0 1. Yes, we can eliminate the options. You see. इतना कहानी दिया, सो इतना कहानी नहीं चाहिए ना हमको. नेक्स्ट वन. Yes, now they given that both flip-flops are positive edge trigger D flip-flops. Okay. The number of states in the state transition diagram of the circuit. Okay. Now tell me now here क्या होगा. So if I call this is my, so we should call this thing here inputs and output. We need to see here carefully. If I call this as my D1 Q1 and this is my D2 Q2. Okay. Let's form a table now here. This is in these cases. I am forming this as a present state. And the input may be क्या होगा? Input can be anything. It may be 0 होगा, 1 भी होगा. We don't know. So in this case, first case, I am taking the input value which is equal to 0 मान लो. Let us consider here. Input will be 0 क्या होगा, 1 क्या होगा. We are going to analyze it. Okay. Input may be 0 होगा or 1 होगा. We are forming a one table, no table form here, present state, and then next flip-flop inputs, and the next state. Let's see this thing here. I will form the table below here. Let us consider the input. I am forming a Mealy mission simply. Present state and the next state, output, and when the input I am calling as x. X is equal to 0 क्या होगा? X is equal to 1 क्या होगा? And we are going to form it. So Mealy mission we are doing now here. The present state and the next state and flip-flop outputs. Now tell me now present. So this is my Q1 and this is Q2. The present state of the flip-flop, it can be anything now here. Let us consider this value 0, 0 we have considered. That means initially this value 0 and this value 0. Okay. Now x is equal to 0. This is x. Input is a x. If the input equal to 0, input, so output we have taken from Q2 is output. So tell me when x is equal to 0, if we after one clock pulse, what I will get, you tell me now. Q1 here, tell me. So Q1, so Q1 which will get this as what, you tell me now, 0. And then this 0 is a input for this flip-flop. What I will get now here, that is 0 only. And what is the output will get now? Q2 is the output, that is output is 0. These are some of the very toughest questions you can say. You need to be carefully, you need to understand. Is it fine, all of you understood this thing? Yes? Any doubt in this thing, tell me now here. These things are very good questions. Listen here. And first of all, understood the table what I formed here. Did you understand first of all the table? Present state Mealy mission we are forming here. So we need to see the how many states are there Mealy mission table we have formed. Isn't it? So here present state initial value we can take it as a 0, 0 we have taken first. 0 0 initial state means what to tell me now here. 0 0 we have taken, and this value, yes, initial values of this value which is equal to 0, this value also 0 we have taken. Now I am giving the x value 0. X is the input now. Input I have given as a 0. If I give the input now here, after one clock pulse, tell me now this now. So here this output will come as this. What is this one? D flip flop now. This will come as output now. Tell me Q1 will come now. Next state. So this is now for this now here. This is the input for this flip flop. So what I will get to tell me now, 0 will come, D flip flop now. Now the output means Q2 value is output. So that's why which we can say this is comma 0. Isn't it? Now let us say now here if I taken the x is equal to 1 we have taken. Tell me what happened. If x is equal to 1, x is equal to 1, after one clock pulse, this will come as output. Now tell me Q1. So this is, it will becomes what we can say here. Now Q1 value which is equal to 1 hoga, and for this value so which is equal to 0 hoga, output is 0. Isn't it? Tell me. Next, this is the scenario when initial value 0 0. Now let us change the value. If the initial value which is equal to 0 1, if the flip flop it is initial value which is equal to 0 1, what happened? So this value, initial value which is this value is a 0, and this value which is equal to 1. Tell me now 0 1 what happened? Tell me now 0 1 what's going to happen. You see, in this case 0 1, in this case what's going to happen, you tell me here. Tell me now, input we have taken as x value 0. If this input value given as 0, so after one clock pulse this value 0 hoga na? Yes, now then this value which is equal to 0 only, and output is at the Q2 is 0. Next you tell me now, when you have taken the input is given as a 1. If I given the input is 1, see what happened. If the input is 1, so what I'll get the output is now here 1 will come, and then which is equal to 0, output is 0. Check this thing all of you. And in case of 1 0, initial state is 1 0. That means this value, initial state of the flip flop which is equal to 1, and this value which is equal to 0. Tell me this kya hoga? Input is 0. If the input is 0, tell me what happens now here. Output will get it as a 0, and this value will get it as 1. So output is 1 Q2 location output. When if x is equal to 1, if x is equal to 1, see what happened, tell me. X is equal to 1, will get this output which will get 1, and this is 1, and output is 1. Now when it is 1 1, tell me here what happened. When this value 0 and this value which is equal to 1, tell me now here 1 1 case what happened. So this value 1, so this input is 0 given, so this value which will come as 0, and this is 1, output is 1. Next, if it is 1, if the input is 1, see what happened, tell me. We'll get this as 1, okay, 1, output is 1. You see, ये टेबल आपको समझ में आया? बोलो, did you understand this table? Tell me all of you. You can see how many states are there, you see. Now if you see carefully, and these two states are exactly same, you see, next state and outputs are same now. And these two states are also same, you see carefully how many states now here. So the effectively how many states are there, you tell me. Only two states are there. Effectively we have, it will appear to be 4 states, but effectively we have only 2 states only, isn't it? क्लियर हो गया? बोलो all of you ये topic. So 0 1, when you given the 0 1 you are talking now here. So initial state value 0 1, right? Initial state, so this value q1 and this q2, this value 0, this value 1. Input I have given 0. Input I have given 0. Now you see this thing here. So the input for this flip-flop is this thing. Input for this flip-flop is, this is the input for this flip-flop now. This 0, this is the output of this first flip-flop, is the input of the second flip-flop, isn't it? Once we apply clock pulse, tell me what happens now. Next state value q1 plus what happened, you tell me, which is equal to 0. So this input will come as output now here. Now you tell me now here, that is q2 plus, and which will become 0. So this flip-flop, this second flip-flop, the input is a first flip-flop, output is a input. Isn't it? All of you tell me. Yes. Yeah, this is a very good problem. Able to follow it or not? And so I think so you might be feeling this is in the last minute we are learning this concept, it is a difficult only. Fine. Now let's see the next one here. In the circuit of the figure, the voltmeter reading is given as 30 volts. The ammeter reading they are asking to find. They given the voltmeter reading, now they are asking to find the ammeter reading. Now you can see now here the voltmeter reading which is given as 30 volts, right? So this given, this is 30 volts. I can say this current in this branch which is equal to 10 amperes. Now here also I can say same kind will go here now. 10 amperes. The 10 amperes is the magnitude of current. If I call this current is a I, now this current which is given as I1 and this current is I2. So tell me now I1, I which is given as phasor form now, I1 bar plus I2 bar I can say. So that I which is given as what I can say, the amplitude is at 10. Can you tell me the phase angle here? So this is phase angle plus 45 now, tell me. And the second one, amplitude is at 10, phase angle how much it is? Minus 45. So tell me now I, the resultant which is given as, tell me. So you can see now here, this is 10 angle plus 45, and here this is 10 angle minus 45, and the resultant of these two which will lies here now, so which will becomes what we can say 20 angle 45, isn't it? So then this value, what I can say now, which is equal to 20, so this is plus 45 and this is minus 45. Yes, now which is equal to 20, both are same direction now, which will become cos 45, tell me. So which is equal to 20 cos 45, which will come it as, tell me now here, 21 by root 2, so which will becomes what now here, 10 root 2. Phasor additions. Now the RMS value of the current shown in the figure is, now they given this is 10 volts, this is 10 10, okay. Now you can see now here which is given as 10 square equal to, that is VR square plus VL minus VC square, means 6 square. So that means VR square which is equal to 8 square, so that is VR equal to 8. VR equal to 8, then I is equal to, tell me now here, 4 amps, and which is RMS value only now. Next, the parallel RLC circuit shown in figure, okay, which is at resonance. So what type of resonance you see this thing? Parallel resonance. In parallel resonance, tell me what happened. Now this is IR, which is nothing but complete current will pass now here the resistor, that is 1 milliamps. Now what else we can say now? IL, which is given as minus J Q into IM now here, which is minus J into Q. Next IC, which is given as plus J Q into IM, which is equal to plus J into Q. Now you tell me now here, IR value, which is, this option is wrong, you tell me. So you see this thing here, and IL plus IC, IL plus IC, how much you tell me? IL plus IC, which is equal to 0. So this is wrong, you see. And what else you see this thing carefully. Now tell me now here, IR plus IL, which is given as, tell me now, 1 milli minus what we can say now, JQ. So this magnitude, if you have taken IR plus IL, this magnitude you tell me now, which is equal to square root of 1 plus Q square. So this value, though I can say definitely greater than 1 milli, I can say this value definitely greater than 1 milli. So what's the option, tell me now? B. Next, now at a resonance, the parallel RLC circuit of the figure constituted by an iron core coil and the capacitor will behave as. So you can see now what is the overall admittance of parallel circuit now. So which is given as 1 by R plus J omega L plus what I can say now here, J omega C. So if I rationalize the denominator, that is R minus J omega L by, so what I can say now, this is R square plus omega L whole square plus what I can say now here, J omega C. J omega C. Now under resonance means what we can say, imaginary part is 0. So that means resonance. So what I will get my admittance, you tell me now here, R by, that is R square plus omega L whole square. This is a admittance. So from this what I can say, my impedance is given as, tell me now here, I can say this is R square plus omega L whole square by R. So then Z, which is given as, tell me now, R plus omega L whole square by, I can say, R square into R. So Z will becomes R plus, I can say, R into this omega L by R, that is nothing but the quality factor. Z is given as R. If we have taken this R common, now you tell me now kya hoga. If I take an R common, then it is 1 plus, which is equal to Q square. So you can see this is the impedance of the network. If you see carefully, this impedance of this network definitely very much greater than R. You see the impedance of this network definitely greater than this R. Okay, option B. Quality factor तो very high value ना, quality factor is very high value, right? Fine. Okay then, yeah, that's for the today's class. We'll meet in the next class.